We are live. Hello, developers. Hello for everyone. And we are seeing some of you saying in the chat that the title is intriguing me. José Silva said this title is a clickbait, but it's not clickbait. You will find the Bigfoot. I can say it for sure. So, developers, today I'm here again with the Guy Rose. Hey, hello for everyone, Guy.
Howdy, howdy. How's everyone doing?
Okay, as you should know, developers, Guy is one of oh, I lost my. Oh, okay, I got it. Is a developer advocate in Redis Labs, and today he will talk about finding Bigfoot with Redis and Redis Search. So please, everyone, smash the like button, share with your friends, subscribe in our channel, and hit the bell for more news. And I think that's it. It's with you, Guy.
Thank you, sir. So yeah, be sure to smash that like button, and don't just smash it, but like smash it extra hard, like with feeling. So welcome everyone to my talk, finding Bigfoot with Redis and Redis Search. So needless to say, this is a Redis talk for Redis month. Let's see what we got here. There we go. As Joano said, my name is Guy Royce. I'm a developer advocate at Redis Labs. There are three things that that matter on this slide here. The first one matters to my boss, one matters to me, and one matters to you. The thing that matters to my boss is this Redis Labs logo right here. Redis Labs is the home of Redis. We fund a nice, healthy percentage of the open source development of Redis, and we have our own Redis Enterprise product. So go check our stuff out, please. The thing that I care about is this Twitter ID at Guy Royce. I like to value my, I measure my my usefulness to the world, my personal value out of how many people on Twitter follow me, and it's around 3,000. So could you please make it 3,001? And the thing that you actually care about is the github.com/Guy Royce. And that's the link where all my code and slides and everything can be found after the talk. So when you're ready to, try and play with some of the stuff yourself, the code is out there to go do that. So github.com/Guy Royce. So that's me. I'm a developer advocate. Please follow me. Thank you for attending my TED Talk. No, just kidding. In addition to being a developer advocate and a developer of many years, I'm also an enormous fan of Bigfoot. There's just something to me that's compelling about Bigfoot. There's this big, hairy, hominid out in the woods, just sort of running around, hiking out there. There's just something that really draws me in. It's just something I like about Bigfoot. There's a mystique to it. And, well, I have to be honest here. The main reason I'm really into Bigfoot is because Bigfoot was my father. He is my father. This is a picture of my dad and me. This is the only photo of him I have. I've been trying to find him for years. I just haven't been able to find him. He's hard to find. There's, very few photographs out there of him. Lots of sightings are reported, but, I haven't seen him since I was a kid. I'd really like to be reunited with Dad. And so I'm on a quest to find Dad. And so the first thing I did was I thought, well, let's hit the stacks, right? Let's go and do the research, look into the journalism, the publications and everything, and see what people are, what kind of articles can I find about Bigfoot? And I found this great article in the Weekly World News. This is a totally reliable newspaper. I mean, I actually, it was right alongside an article on Elvis, My Baby Was Replaced by a Baby Clone of Elvis by Aliens. Lots of quality research coming from this newspaper here. This is actually, I remember this day. This is a picture of my father and I. We had just stolen a bunch of apples and we're running through the woods. I'm there in my whitey tighties. And so this is what I found when I looked through the stacks. I found my past, not the future. I didn't find my dad. I just found things that I was present for. And so I thought, well, if I can't find it from the journalists, maybe I should go to the fine folks at Discover, at the Animal Planet, the Discovery Channel, for their wonderful show, Finding Bigfoot. Um, this image cracks me up, and not only is the meme kind of funny, but this show on the Discovery Channel is set up, and they've got 3 true believers that are looking for Bigfoot and 1 skeptic. And what makes me laugh about this is that the skeptic is kind of obvious when you look at it. Everyone else kind of got neutral looks on their face, but the woman in the middle has this face, sort of vague look of disgust, like, oh my God, what have I done with my career? And she's just, she can't believe she's working with these guys. And so, needless to say, the people that don't always find Bigfoot, but when they do, they don't, were not able to help me find my father. But actually, one of the guys, I think it's the guy on the right there, founded an organization. And that organization is called the Bigfoot Field Researchers Organization. Founded in 1995, the only scientific research organization exploring the Bigfoot Sasquatch mystery. This is a screen capture from their website. They've got a website full of data. It's clearly founded in 1995. I mean, if you look at the styling and design on this website, this is not something that was built recently. It looks like they haven't updated it since it was built in 1995. And when you go there to the website, it's got a bunch of articles for humans to read. So you go through their database, and you think database is like rows and columns. No, it's not rows and columns. It's like a bunch of Word documents. It's just a bunch of HTML files. And it's like, Bigfoot sighting number 8086, saw Bigfoot near Wayne National Forest. That's the sort of sighting it is. It's great for browsing, but it's not good for searching, and it's not good for finding. You can't see them all. You can't find a pattern out of it. And so I've got information, but I don't have data. So how do I turn the Bigfoot Field Researchers Organization, the BFRO, their information into data? Well, fortunately, the internet has everything. This is a man by the name of Timothy Renner, and Timothy likes weird data. And he has gone through and written a bunch of Python code to do screen scraping against lots of these weird sites, like the Haunted Places Index and the Bigfoot Field Researchers Organization, and there's a UFO research center. And he's screen scraped all over their reports and made data sets, and he's been doing data science with them. It's actually really funny because the data science that he did for the Bigfoot sighting said he plotted them all out at their locations, their latitude and longitude, across all of North America. And then he used clustering to figure out the natural groupings of these sightings. And it's like, okay, but why are these clustered the way they are? And he overlaid a vegetation map and realized that looking carefully at the map, that you could find Bigfoot in the woods, which is a great conclusion, but not very helpful. He did a similar thing with the UFO data, actually, where he found out that most of the UFO sightings happened within 50 miles of a U.S. Air Force base. And most of them happened on Independence Day during the fireworks celebrations. So lots of reality being exposed by the data that he has screen scraped and put together. So Tim Renner is one of my favorite humans because he's provided me with this great data that I've gotten so much mileage out of. So Tim, thank you very much, as always. And so he turned this data into something, actually rows and columns, a CSV file, something that I can use and actually do some searching against. The data consists of just a bunch of fields. Each report has an ID. That's the unique number of that report. So report number 8086, which actually happened to be the microprocessor in my first computer. The date of the Bigfoot sighting, this one is on January 15th of 1958. The title of that sighting, this is just sort of like a title of the report, just like the title of a chapter in a book. The title here is "A series of large human-like footprints are found on a farm near Wayne National Forest," which is not far from where I live, actually. The observed, which is sort of the eyewitness account. This is the person saying, while doing some yard chores, we noticed a series of tracks going into the hollow on our property. Upon examination, and then the dogs went crazy and we heard a weird noise and that kind of stuff. It's that account of having seen it. Bigfoot sightings also have a classification. You might have heard of UFOs having a close encounters of the first, second, or third kind. Bigfoot sightings have a similar thing. Bigfoot sightings have a Class A sighting, which means we saw Bigfoot. Hey, there he is. Class B, we found evidence of Bigfoot, like a footprint or maybe hearing some noises or something like that. And a Class C Bigfoot sighting, which is someone told me they saw Bigfoot. Obviously, the most reliable of all the Bigfoot classifications. We've got county and state. This is data for North America, so it's all based on U.S. states and counties. We've got a latitude and longitude of where that Bigfoot sighting occurred. And then we've got location details, which is sort of like a description from the person saying, here, its closest town was Harrietsville. The closest main road is State Route 145. It's right on the border of Noble and Washington counties. So sort of a how to find this once you're in the area sort of details. This is the BFRO's data. Now, Tim actually went through and blended in weather data for all these because he's got the dates and he's got the latitude and longitude. And so he went to dark sky and pulled weather data. And we also have the high and low temperatures for that particular event, what the humidity is and the dew point, cloud cover, what the moon phase was. So maybe maybe Bigfoot only shows up on full moons. Whether it's raining or not, maybe, if it's rainy and the visibility is poor, that you might confuse grizzly bear as being Bigfoot, that sort of thing. And so there's a lot of really fun data here for us to search through. And so I've got a data source, and this is all in a nice, neat CSV file. I'll show you the CSV file right here. I can get it to click over. It's not doing what I want. Oh, well. But I want to get that CSV file, and I'm going to store it in Redis. That's my goal. And I can store this data in Redis in a lot of ways. I'm going to assume we're here relatively familiar with Redis because this is obviously Redis month, and you've probably seen a lot of Redis-themed talks tonight. But if you're not familiar with Redis, it's sort of like take a network connection and have all those data structures that you learned about in data structures class in college on the other end of it. So rather than having a hash table or a set or a list in your code, you can have it over the network and in Redis. And so we say it's like an in-memory NoSQL database, or sometimes people say it's a key value store. It is a key value store, and those keys contain different types of values, which are different data structures. They might just be a string. They could be a list. They could be sets. They could be hashes. Lots of different data structures can be in there. We could represent our Bigfoot data in a few ways. We could store stuff in strings. Strings aren't necessarily just like strings like text. They can also be binary strings. We don't have any in this particular example, but we just have text. But you just use the set and get commands to set a key name and then its value, and then you can get it. So here we're setting Bigfoot : sightings : 8086, and then classification. So that'd be the classification of sighting 8086. The state would be Ohio. Ohio is where I live. We could use lists. Like maybe we want to keep a list of all the text of the new Bigfoot sightings. So as they come in, we can process them. And so we could push things onto lists and pop things off those lists and use them as queues, actually, or stacks if we want. And so that's another way we could store some of this Bigfoot data into Redis. We could use sets. Sets are like the Venn diagram set sort of things. It's really great for deduplicating things. We could build indexes using our sets and say, the Bigfoot sightings by the state of Ohio, add some here, and then we could check using sysmember. And of course, we could use hashes. And hashes are actually what we're going to settle on. It's the most logical case if you've got tabular data, right? So here we've got, we're setting specific fields. So we say hset, and then a key, Bigfoot sighting 8086, and then the field classification within that hash table. And then we get a value. And then we set the state to Ohio, and then we can get values out of it as well. So we're going to use all of our BFRO data is going to be represented in Redis as a hash. So here we got a really big hset where we're setting that 8086 that we looked at earlier with all that text. And, there's some dots here because it doesn't all fit on the screen. But this would be the syntax we'd use to represent that data. So we can store all this data in Redis, but how do we find it? How do we search for it? Well, the easiest search is to just bake it into the key name. So this key name has a namespace. Say this is for the Bigfoot thing, and this is a sighting as opposed to, say, some other thing. And then we can put the ID or the report number as part of that key. And so if we want to find report number 8086, we know the key name to go looking for it. So we just build that string and we go look for it. We just say hgetall and get it. And that's a really easy way to query data, but it's pretty limited because I can only get data by my ID. I can't search through the data and find specific variations. I can't find Bigfoot sightings that happen in a particular place or around a particular time or, anything like that. And so that makes it a little harder to find my dad. And so one way you can solve that is to set up indices as sets. So the idea here is that I can create a set that has, in the first one here is Bigfoot sightings by state, Ohio. So this would get all the Bigfoot sightings in the state of Ohio, and it's got the IDs. And then if I wanted to get a list of all the states in Ohio, I could then say, or all the Bigfoot sightings in Ohio, I could go and do a S members and get all those for Ohio. That's the IDs. And then I could build those keys and go look them up like I did for if I knew the ID already. And I could do the same thing for other keys that I want indexed. So if I want to do by classification, I could have Bigfoot sightings by class B. Of course, I would have one of these for every value in the class and one of these for every value in the state. So there are 50 states in the United States. So that's going to be 50 sets for that. There are 3 classes of Bigfoot sightings, and so we'd have 3 sets for that. So we're up to 53. We could probably take Hawaii out of there. I don't think there's any Bigfoot sightings in Hawaii. Aloha, it's Bigfoot. But you can see how this is easy to do, right? But you can also, you start getting a proliferation of keys really quickly here, a lot of sets. And using them is pretty easy. If I just want to get all the Bigfoot sightings in Ohio, I could call S members, set members, or SMembers, as I like to say it. And then just say Bigfoot sightings by state Ohio, and that will just give me all those IDs back. If I want to do, give me all the Bigfoot sightings in Ohio, which is where I live, and Kentucky, which is a neighboring state and the home of bourbon, so it's my second favorite state in the United States, then you could do a set union or a S union. And then that will take those 2 sets, union them together, and then give you all the IDs between them. And so now I can then use those and do hgetalls to get all those Bigfoot sightings. And I could even mix keys together. So if I wanted to get all the Bigfoot sightings that happened in Ohio and were class B, I could do an S inter for a set intersection, or a center, as I like to call it. And so this is a fairly simple way to do some basic indexing manually in Redis without using any special tools. Open source Redis does this right out of the box. You're able to do these. They are kind of limited, however. There's a few problems. One of them is these indices in general. One, and I mentioned this earlier, is you have a lot of them. And you have to create them. And you have to manage them. So let's say I want to take my Bigfoot sighting 8086, which is in Ohio and is class B, and I change it. And so instead of being Ohio class B, it's now Kentucky class A. Well, now I got to update the indices as well. I have to remove 8086 from the Ohio index, and I have to add Kentucky 8086, or add 8086 to the state Kentucky index. And I got to do the same thing for the class. I got to remove it from class B and add it to class A. So that's a bit of work. It's manageable, but you're writing a lot of code to manage these keys. The other thing, though, is that this sounds straightforward. I mean, it's 5 Redis commands, but those Redis commands aren't atomic. So if the orange user here says, let's update the state and the classification for Bigfoot sighting, for a particular Bigfoot sighting, then someone else comes in and says, well, I want to get all the Bigfoot sightings in Ohio. They're going to get 8086 back because that set hasn't been updated yet. Then the user comes in later and updates the set. And so the green user has outdated data. This is classic race condition, right? And so making these atomic is then another complication on top of just managing them themselves. You can do this in Redis. You can use multi to create a transaction around this. Redis uses optimistic locking, so then you have to watch all the keys that might change as a result of all the things that were going to be in your transaction, and if they change, you pull them out. And so that can help, but ultimately, this just starts to break down pretty quickly. There's another problem too, and that's that you really can't get the full range of queries that you might want. Like we're used to using SQL to query relational databases. These seem a lot more powerful than these indexes that we've built, right? Let's say I want to find all the Bigfoot sightings that are in Kentucky and Ohio. We've talked about how to do that. We just use a set union. It's pretty straightforward. Union Ohio and Kentucky, that'll get to give us him. By the way, Ohio is the one to the north here. This is where I'm like right here in the middle. And then Kentucky is where my grandfather was from, actually. It's my ancestral home. And he was from over here. But this is a straightforward one. We can still do this with this mechanism. But let's say in addition to being in Kentucky and Ohio, I also want to find ones that are from a particular class. Class B, evidence of Bigfoot. And so I need to do an intersection, but how do I need to do an intersection between the Class B index and what? Some other thing, some index I don't have. Well, we can solve that. We can do a union store, an S union store between Ohio and Kentucky, and save that off as a temporary set of the union of Ohio and Kentucky. And then we can do an intersection between the Class B and that temporary set that we created. But now we have a set that's sitting out there, and we need to delete it or expire it. And so we've got one more thing to manage. And so this is possible, but the complexity starts to spiral out. Let's say that in addition to finding all the Bigfoot sightings that are in Ohio and Kentucky and that are Class B, we also want to find the ones where the temperature is greater than or equal to 75 degrees Fahrenheit. Sorry, I don't know what that is in Celsius. I think that's like 25 in Celsius. Well, that's, I don't know. I can't build indexes to do comparative greater than less than things. That's hard. And let's say I also want to find ones that have in the description, in the overview, or in the observed, eyewitness account, that have the word creek in it. And I want to find ones that are within 50 miles of, which would be about 90 kilometers, of Cincinnati. Is that right? 90 kilometers? Not close enough. So have the word creek. So we're talking like text search. We want to find a subset of it. And we want things that are geographically bound. How do I do that? I don't know. The answer is using this technique, you can't. And this is the problem that RedisSearch solves. RedisSearch is a module that you can add on to Redis to extend its capabilities. It's part of Redis Enterprise. You can go to Redis. You can get a Redis Cloud account and just set one of these up very easily. But you can also install the module on a local version. I've got it running locally. I tend to run all my demos locally because sometimes I give them in person, and the whole conference demons will always conspire to make the Wi-Fi bad. So even though this is online and it's my Wi-Fi, and if the Wi-Fi fails, we're done anyhow. It's all set up to use Docker. But you can use Docker images. You can use Redis Enterprise. But RedisSearch is a module that adds new capabilities to Redis. It adds indexing. It lets us build these indexes that I've been doing manually with sets very easily, and makes it atomic too. It adds full text search capabilities, so I can say, give me all the Bigfoot sightings that have the word Walmart in them. There are some, as it turns out. And it understands that it's a language and understands the various languages. So it'll understand the words that are important and not important, and words that are related to each other. So it understands that it's text and it's language. And it actually adds aggregation capabilities as well. This would be the sort of the group by stuff that you would do in a SQL statement, where I want to group all the Bigfoot sightings by classes, and then get, say, the average temperature for a Class A, Class B, or Class C sighting, or something like that. And so RedisSearch app gives us all these capabilities and a few more, but these are the ones I'm going to touch on in this talk. To create these indices, instead of creating all these sets and manually maintaining them over the course of everything, you can instead use the ft create command and create an index. And this first thing right here, Bigfoot sighting index, that's the name of our index that we want to create. We are telling it that we are going to index hashes, which is good because we've stored our Bigfoot data in hashes. And so this index knows it's going to monitor hashes for changes, and if there's changes, it will update its index. It has explicitly been instructed to look at 2 patterns of keys, hashes that start with keys of Bigfoot sightings and UFO sighting. So if it had some other thing like, say, ghost sightings, those wouldn't match either of these patterns, and so it wouldn't be indexed. So you're giving it a prefix. And this 2 right here is just saying that there are 2 values here. That's all that means. So we're saying create an index on hashes, look at keys that contain hashes that start with either Bigfoot sighting or UFO sighting. And then we give it a schema. And the schema takes those field names in that hash. And so that's the first thing. So we want to take, say, the observed or the state or the humidity or the location, which are all fields in that hash. And we want to treat them as a particular type. So the observed, for example, is text. So full text search would be used against that. The tag is more of I care about the whole value here. You use it for like IDs and unique things. It's used for like state names or county names, that sort of thing. Numeric is, well, it's numeric. It's for numbers. We know what numbers are. And geo is for geolocation. So if you've got like coordinates, you could tell it this geo. And you can optionally make these sortable. Usually you want to. But if you don't make them sortable, you can sort them manually later, but then makes it a little slower, but it takes less space in memory. So it's a trade-off of performance versus space. But this creates a really basic index. Once we have that index, we can then start doing queries. And the query is actually pretty straightforward. We use the ft.search command. And then we give it the index name that we created and a query. So this is the index. And this is our very super complicated and sophisticated query. This query is in quotes. It doesn't have to be in quotes, but if there's any spaces in it, you need quotes. So putting in quotes all the time is a good practice. And star just means match everything. So this will return all the Bigfoots. You can put a limit on it. You can say, I want to start at position 0 in all the results and give me 3 items. So this is our starting index, and this is the number of results we want back. And I can specify the specific fields I want to return. So I can say, return 2 fields out of those hashes. I just want the ID, 8086, and the state, Ohio. And so that's how it works. And that command will do a search. The result will come back in this format here. So you get at the top here, you get the total number of sightings. So there's 4,586 sightings in the Bigfoot data set. And then it's alternating the key name in Redis it's stored in. So that's in positions 2, 4, and 6. And then the other alternating index here is, or value here is the actual values that are in that key. And since that's a hash, that is nested here. So we got an array of arrays. And those are alternating key value. So there's ID, and then the number, and then state in Mississippi. And I'm actually I've got this little section for demo here, but I think I'm just going to go ahead and do the demo right here in Redis. So I've already got this stuff loaded. I'm going to show you the code here where I load this, or where I create the indexes. So this is a Node.js code here. So I go and I delete the existing indexes and get a list and drop them. But here I'm calling ft create. I'm giving it the index that I want on hash prefixed with one thing. This little config value turns is Bigfoot sightings. And then I've got my big schema here. I'm saying the ID is a tag and it's sortable, and the title is text and it's got a weighted 2. And we'll get into what some of these things mean here. But this is a pretty easy way to create an index. You can also create indexes on JSON, by the way. The syntax is a little different here. And all this code's up on GitHub to look at. But here you're doing a path into that JSON document, and then you're giving it an alias. So $.id would get the ID property at the top of the JSON document, and then we're renaming it as ID. But if I run this, let's go ahead and run this. npm run load create. It's npm run index. There we go. And there it's going, and it's done. Very exciting. Look, it ran. Now, if I go to the Redis CLI here, I should be able to say ft.search, and we want the Bigfoot sighting index, and let's just get star, and there we go. I got a whole bunch of them. I don't want all this thing, so let's do limit 0, 1, return, or 0, let's return 3 of them. Let's return the ID in the state like I did in the other example. There we have Mississippi, Georgia, and Michigan, just like we did on the little slide there. It's actually kind of fun. You can take this return, and if you just want the key names and you don't want the values, you can say return 0 and say return with no arguments. And now I just get the key names back. And actually, if you don't want even that, you can just say limit 0, 0, and it will start at position 0, return 0 things, which means it doesn't return anything, and that will get you just the count. So we're able to get just the number. So there's a couple ways you can do this. So it's a real thing. I mentioned this earlier. There's 4 types of fields. We got text fields, tag fields, numerics, and geolocation. Text field is that full text. Text fields. Sorry, I just saw your question, Jose. The text field is that full text search. The tag is those tag cloud kind of things. They are I think of them kind of like enums, but they can be comma separated lists. So if you have like a field is like a bunch of states separated by commas, you could say, and it matches one of these tags. A numeric is the numbers, and geo is the geo. And yeah, Jose, you asked, is it I'm running on bare metal, Docker, or in the cloud? I'm running in Docker, actually. Right here, if I show you, I've got my Docker Compose up that I ran earlier. That is my my Docker image. And if you look here, there is a Docker Compose file right here. And no, I don't want to do that. Thank you. There we go. So not a very complicated Docker Compose file. I am running Redis mod Edge. Redis mod's a Docker image that has all the Redis modules in it. So I want to bring my terminal back. There we go. Yeah, no problem. No problem at all. Yeah, I generally run it in Docker. It's for a self-contained environment, it's the easiest way to do it. And again, if I run it cloud for conference Wi-Fi is notoriously bad, so I never want to rely on anything external. The cloud product itself is fantastic and easy to use, but it's it's the network at the conference. It's always dodgy. No, actually, it doesn't. We have our own thing in there. I don't know what the thing is that we're using internally. I know how to use it from external. I think there's a C library that we're using to do something, but it's not Lucene or Solar or anything like that. I think there might be some text libraries that do that. There's some C libraries for that purpose. I don't know what. I remember reading about it in the Redis documentation. I just don't remember what it's called. But it's definitely not Lucene and it's definitely not Solar. I've used those products in the past. So let's look at how the text works, though. So to do a text search, here I've got a simple create where I've just got the title and the observed, and I'm making them text, and they're not sortable, and that's okay. To do a search on text, it's actually just passing the word. And so, like, if I want to find all the Bigfoot sightings containing the word creek, then I could just go out here and say, and limit 0, 3, return 0. So those are the 3 Bigfoot sightings that have the word creek in them. If I want to do, say, creek and river, this would give me all the Bigfoot sightings that contain the word creek and the word river. It's and by default. So if I go over here and do that same search again and add creek and river, we'll see that the count goes down from 827 to 174. So it's finding fewer results. I could say creek optionally contains river. Doesn't have to, but if it does, it will score higher. So if I go over here and do that, a little tilde there, my count goes up again. Goes to 827. I could say creek or river. So using that little shepherd stroke there. I can say creek or river and stream by using parentheses. So you use those parentheses in a very intuitive way, the way you do when you're programming anything else. You could say creek or river and put a little dash in front of it and say, and doesn't contain the word stream. So we've got a lot of really, lot of ways to search text here. And so that's pretty much all the operations for doing full text search. Yeah, I forgot about this one. You can also you can specify the field you care about. So instead of saying, like what's happening here with the creek and the creek river is it's looking for all the text fields that are in that index. And if it's in any of them, it will return it. However, if you want to be explicit and say, no, I only want the word creek if it's in the title, and I only want the word observed, it's in the river, then you can use this syntax right here to make that happen. You can specifically say, search only this field. And this syntax is actually really relevant later on because most of the other search mechanisms only do this. The name for this language, Jose, is well, it's just the RedisSearch. This is just there's no specific language that this is called. This is the syntax that was created for RedisSearch. So I don't know that we have a name for it. I think it's just RedisSearch. You can weight the text a little bit. So here, when you set up your schema, you can say the title, for example, is twice as important as the observed. And so that when you then go out and do these queries, things that are in the title, if you're looking for the word creek and it's in the title, that's going to make that document more important than if the word creek was just in the observed. And so that's another capability. It's something you would expect with full text search. It has a whole bunch of stop words, so it understands that certain words are common in a language and so aren't relevant. Here are all the English stop words. These are the default ones. It's the words you would expect to see: a, and, are, the, it, no, not, those sorts of things. And so when it's doing the creating the index on that full text search, it doesn't. These words aren't searchable. And it also understands stemming. This is the idea that or it performs stemming. This is the idea that words have variations in them based on their linguistic purpose, but they mean the same thing. So if I search for the word give, it would also return things that contain gave, given, and giving. And by default, it uses English, but you can tell it a bunch of other languages here. Portuguese is amongst the lists of languages it knows about. So however, annoyingly, the stop words are still the English stop words, even if you tell it to use Portuguese. So if you are using this for Portuguese, then you would want to put in Portuguese stop words, which can, when you set up your schema, you can give it a list of specific stop words. Or you can just turn stop words off even if you want. So this means that I can do the search for creek. That was one of the ones where I'm like, what? How do I do this? Well, I can just look for creek. I've got the capability to find the creek. Now I can find, Bigfoot sightings that have the word creek, but can I find ones that have that are in Ohio and Kentucky and are Class B? How do I do that? Well, to do that, we need to use tags. And so a tag is sort of that enum-like thing. We care about the whole value. We don't care about it as text. We're looking at it as sort of as a value in itself. Ohio. We don't want to look for the word Ohio. Like if we have the word West Virginia, then West Virginia is 2 words, but we don't want it to come up with the word West. We're looking just for that state, right? And so that's what tags solve. They solve that sort of problem. The search syntax for a tag is a little different. You always have to specify what field you want to look at with a tag, and then you put it in curly braces. So at state : Ohio will find all the Bigfoot sightings in Ohio. At state Ohio or pipe Kentucky will find all the ones in Ohio or Kentucky, and Kentucky really. It's an or. So if it's in Ohio or if it's in Kentucky, return it. You can do a query for Ohio and Kentucky, so it must be in both states, which doesn't make any sense, but you could write a query for. Here we're looking for the state of West Virginia, and you'll notice there's a space in here, and I mentioned this earlier with the idea of searching. There's a few gotchas in here. West Virginia will work fine, but if you go to do a classification, the letter A right here in Class A will be triggered as a stop word, and it'll be parsed out, and it'll give you a syntax error. So if you want to find ones that match Class A, you need to escape the space. And so escaping your spaces in these queries is a good practice. And here's that and. This would find classifications where classification is Class A and is Class B. So a Bigfoot sighting where it has both of those classifications. Maybe you saw Bigfoot and you found a footprint. And you'll see there's a quote here and a quote here. So that's within that quote. And so I can demo these really quick here. Let's go ahead and add to our creek example and say at state : Ohio or Kentucky. And that's going to limit us down right there from we're down to 68. And let's add classification. I'm going to show you the error you'll get. If you type in Class A, sorry for the word wrap there, you'll get a syntax error. It doesn't know how to parse it. And if I escape that value here with a couple of backslashes, now it works. So we're down to 35 Bigfoot sightings in our query so far. Cool. We want Class B. Let's make sure we have this correct. Class B. For Class B, we actually don't need to escape it because it's going to parse it okay, because there's no stop word in there. So we've got 33 Bigfoot sightings that are in Ohio or Kentucky and are Class B and have the word creek in them. So we're getting there. We're getting there to that crazy query that we want to do. So there we are. State: Ohio, Kentucky, classification, Class B. Numbers. So you might remember the other crazy query we want to do. We wanted to say where the temperature was above 75 degrees, equal to or above 75 degrees Fahrenheit. Well, we defined a couple numbers here. We got our high temperature and our low temperature. And we can call search again. But instead of searching with curly braces, now we use square brackets. So we're saying at temperature high, so this is our field we care about, colon, and then square brackets. And the square brackets then give us our temperature range. We want 60 to 75 degrees. So, and that's inclusive. So 60 or higher, 75 or lower. And it'll give everything in that particular range. You might want to do, say, 60 degrees and as high as it could go. So you can do positive infinity. You can also do negative infinity, so that'd be 75 or lower. And you can even do negative to positive infinity, which just confirms that it's a number. Sometimes the temperature data might be missing and it might be nil, which would not be a number. This would filter those out. If you want it to be exclusive instead of inclusive, you can put a parenthesis there to the left of the number. And so this would get everything above 60 degrees, but not 60 degrees, and everything below 75 degrees, but not 75 degrees. So you can also make it exclusive instead of inclusive. And so that allows us to expand it out and say, let's get our temperature with a high of 75 or more. So let's go back and let's keep refining this query. So we've got we got the word creek, we got the state, we got our classification, and now we want at temperature high colon 75 to infinity and beyond. And if we hit return there, we now are down to 11 entries. So we're really narrowing this down. Greater than 75 degrees, Class B, Ohio and Kentucky. Cool. So let's look at geolocation. I've had puns for the titles for everything, but I couldn't think of a good pun for geolocation, so I just made it punless geolocation. I really like this sculpture here. I don't know why. It's just really goofy looking. I think it's because Bigfoot has blue eyes, which is just the weirdest thing ever. It's like you wouldn't expect Bigfoot to have blue eyes. It's just very, very strange. So when we do geolocation, there's a special thing we have to do with the field. So the field that we say is a geofield has to be in a specific format. And that format needs to be longitude, comma, latitude. Negative is west, positive is east, positive is north, negative is south. So this is actually the location for Cincinnati, Ohio. First value must be the longitude. Second value must be the latitude. Now, I don't know if this is true in the Portuguese-speaking world or not, but in the English-speaking world, we always say latitude first and then longitude. And so this always trips people up because the convention in English is to say latitude and longitude. Redis goes longitude-latitude instead. And that's because Salvatore Sanfilippo, who created Redis, is Italian, and apparently that's the way they do it in Italy. So so this may be very intuitive to you, or it could be backwards to you, just like it is to me. But either way, it must be in that order. So it's got to be longitude, latitude. So if that string is in that format, then we can treat it as a set of coordinates and treat it as a geofield. And then we can do queries on that. The query here is very similar to the range query. Here we're looking at location, and then in square brackets we put the longitude, the latitude, the distance we want to look, and then the units we want to use. So this is saying these coordinates, which is the downtown Cincinnati, Ohio, 50, and then miles. It knows more than miles. It also knows feet. So I'm going for all the freedom units here first, of course, right? And then it also knows meters and kilometers, which is for the rest of the world who's using rational systems of measurement. And so, but it's just internally, it's just calculating them all as I think as meters. So, and so this allows you to query things at a particular location as well, and within a radius of a location. So we can add to our query here at location, just like I showed you there. And I'm going to go ahead and put this in here as well, and we'll get our sort of our final dream query. Location colon, and then it's minus 83 point something, 84.5120. Yes, it has to be correct. 39, I think, point 39.1031. I want it to be within 50 miles of Cincinnati. So it's two of them. So we've got two of those sightings that match that criteria. Cool. So putting it all together, this is the query I just typed in. We can just do this one big search here. I've got spaces in here to make it fit on the screen. Redis CLI prefers it to be one line. However, you can use Redis Insight here. It's got a search feature as well. And I can go to search, and I've got a, where's that here? Yeah, there it is. I've got that bit right there. I don't need to copy this bit for it. Because I'm saying search, I say my index, so it knows FT search, it knows the index. So Redis Insight is a GUI for Redis that's is available for free for download. And it is perfectly happy to handle no, that's right. Handle carriage returns and stuff like that. It doesn't mind that at all. Although it all fits on here, so it's not that big of a deal. Here we go. That is, I think I have oh yeah, I don't have the class in there, so it's not quite the same query. Let's copy that back up there and put at classification colon curly relace class. There we go. There's our 2. Totally works. It's a little friendlier of a tool in some ways, although it's nice having the CLI right here in next to my code and everything. So, but yeah, so you can do very complex SQL-like queries, right? You can find exactly what you're looking for. This is my demo slide. Obviously, I just did the demo, so we don't need this. But that is a nice bike, isn't it? Here's some SQL equivalents, just sort of as a reference if you download the slides later, for some of the common SQL queries and what those would look like when Redis search. And yeah, so let's talk. We've talked about search. Let's go into aggregation here. I'm going a little bit long here. Apologies. But aggregation is sort of the group by piece of it. And so aggregation lets you take those rows you get back and collapse them down into into things where you count them and average them and sum them up and those sorts of things. Its syntax is initially exactly the same as Redis search. Instead of calling ft.search, you call ft.aggregate. And then you pass in your index that you want to use and you give it a query. And here I'm querying with star. Give me all the records. But after that you've done this, it changes because you can run it through a pipeline of filters and transformations where you can create aliases and new fields. Filters where you can reduce, filter out some of the values you return. Grouping where you can group it by different fields. And sorting. And you can, it doesn't have to be filter, transform, group, sort. It can be any complex pattern that you want. You can filter things a couple times, group them, filter them again, transform the results of that filtering, and just build any pipeline you want. Filtering is sort of an alternate syntax to searching in a way, because the search, when you pass in that star, it's going to give back everything. But once you get that everything, you can provide filters as well, or you can have a query and provide filters as well. So here we've got a filter where the temperature high is greater than 75. And so this filter syntax is, you say filter based on this condition, and it's using sort of greater than, less than, the kind of things you put in an if statement, right? This will be a very familiar syntax. Here, if we want to say where the humidity is greater than or equal to 80%, or the temperature, the high temperature is less than 80 degrees, so where it's humid but not so hot, you could do transformations of these before you do the comparison. So here we're saying the humidity is greater than 50%, and the humidity modulus 2 is equal to 0. So the humidity is greater than 50%, and it's even. Which is a useless query in a lot of ways, but it's just showing that you can transform these values before you do the comparison. So this is all the kind of stuff this is like writing code, right? And you can call certain helper functions, like you could call exists. Does the high temperature exist, or is it nil? Nil will return 0 and it will filter it out. Anything else will return true and return it, or return a 1. And you can take those function calls and do comparisons against them. And you can even you do timestamps. So it'll take a Unix timestamp, and you can say, give me the day of the week for this Unix timestamp. And so this particular filter filters out Sundays. So it says, give me all the days that aren't Sunday. So, give Bigfoot a break on Sunday, right? So lots of ways to filter here. The syntax is very, very intuitive. There's a whole list of functions here that you can use. I'm not going to go into all these. You've got various numeric and string functions. Like you could uppercase the string and then compare it to say, is this the uppercase string equal to this thing? Or you could get the floor of a number or the absolute number. Extract all kinds of date time properties. The geo distance things are neat because you can give them two fields that are latitude, longitudes, and it'll give you the distance between them, and then you can use that as a comparison, which is kind of cool. That's filters. You can also transform. Transforms allow you to create new fields, and it uses the apply keyword. So you can create new fields either by renaming them or by actually doing some math against them or some function calls against them. Here I'm taking the high temperature and I'm aliasing it as high_F because it's the Fahrenheit temperature. And then I also use an apply that takes the high temperature and converts it to Celsius for the rest of the world. And so now I have two new fields, high F and high C. I can call functions inside of applies. I can say, does this exist, and make that a function, make that a field that I can look at later on. And then exist returns a 0 or 1. I can ask for the month of the year. So this particular apply is getting the month of the year from a timestamp and adding 1 to it. Now I've got that function plus a math operation. This will month of the year gives you 0 to 11, so add 1 gets January through December. And again, these functions are exactly the same functions that you can use in filters. You're just transforming them instead of filtering on them. So that's transformation. You can group. Here we want to group by a couple of fields in our record and collapse them down and say, for each state and classification, give me a row. So here I'm it's just like group by with SQL. And so I would get 150 results back in this case because there's 50 states and there's 3 Bigfoot classes. So this would give me, that would collapse all my data down to 150 rows. And then you've got these reducer functions. Here we're reducing by counting. So for each group, count the number of rows and make it a field called count. And this count right here is sort of a hard-coded thing. We've got a small collection of those. For example, you can do multiple reducers in a group by. We're getting the count. We could get the average temperature here, and that takes 1 argument, the variable name here. This is taking 0 arguments. And so we can get the average high, the average low. We can get the max temperature from our entire, for each state and classification. We get the minimum temperature from the low temperature. And so we're able to just make all these fields on the fly. Oh, that's really interesting, Jose. Thank you. Yeah, it was actually created by an Italian, and Salvatore is Italian, so that checks out. That's really cool. Very, very cool. Another thing you do with group by is you can group by 0. So here we're saying group by 2 and then provide 2 fields we want to group by on, right? But if we do a group by 0, it means collapse my entire data set down to a single row and then do reducers on this. So in this case, I'm reducing and getting the highest temperature in the entire Bigfoot data set. I'm getting the lowest temperature in the entire Bigfoot data set. And here I'm getting the quantile of 0.5. So that gives me the median temperature from the temperature bit. So lots of ways you can group these things and all these reducing functions that you can use. This is a list of all the reducers that we have. There's some basic count distinct. Count distinctish is neat. It uses a hyperlog log, so it's a probabilistic version of counting. And you've got sum, min, and max. It's all the things you would expect to see, right? Basic math operations, standard deviation. You can convert them to a list as well. And you get the first value, you can get a random sample. Lots and lots of reducers here. I haven't played with all of them yet, but there's several to choose from. And so that's how you do that, that grouping. And then the last thing, we did filters, transforms, grouping, and then we can do sorting. And sorting is actually really simple. You just say, here's the fields I want to sort by. I want to sort by state and county. If I want to make them ascending and descending, I can explicitly do that. It's ascending by default.
Yeah, I think you're already in the question, right?
Yeah. I paused for a moment just to read the question here.
Okay.
Is there a slideshow that some SQL equivalents, but that command contains all RedisSearch commands? There is. It was a few slides back. I don't have one for the group buys. I didn't have time to create one when I was putting this talk together, but I do want to get one for the group buys as well. But it's, let me see if I can jump back to it here real quick. Where are you hiding? There we go. So I do have a slide for that. And this is actually on the Redis search, RedisSearch.io as well. It's actually, I copied and pasted it from there and turned it into This is just for the where clauses. There's not an equivalent for all the group bys. And I'm sure there are things in SQL that you can't do, that you can do that you can't do in RedisSearch and vice versa. So they're not 100%, it's not 100% equivalency there. But yeah, so this is some of them. I need to build a slide that shows the, group by equivalence here as well. So let me hop down to get back to where I was at here. There we go. We were looking at sorting. Yeah, it'd be kind of cool to show. Maybe I should enhance this talk a little bit to show some equivalent queries. So yeah, here's this Redis search query. Here's how you would do it in SQL. So you could say, here's this SQL problem I have. Here's how you would do it with Redis search. I think that would be useful. So I may make that change. So thanks for the feedback. So sorting. So I'm almost done here. I've got some fun queries that sort of put all this stuff together. And it lets us look at the data a little bit because the data is kind of fun. So this counts all the Bigfoot sightings by year and month. So I just want to know over time for, January of 1970, February of 1970, all the way up to the end of my data, how many Bigfoot sightings there are. And so here we've got, that same search aggregate Bigfoot sighting index. I want to find anything where I have a timestamp between 0 and infinity. So I want to make sure it's a number. And negative timestamps aren't valid, so I did 0 to infinity. And so that's my search. Then I apply to that timestamp value. I use the year function to pull the year out. I use the month of year function to pull that month out. So is it January, is it December? And I name that month. I group by that year and that month, and I get a count. I reduce it as a count. I sort by the year and the month, and I say, just give them all to me. Right. I just set it to 10,000 because it was a really big number, right? And that query totally works. I can actually show it to you here I've got it. I'm going to do it this way here. So if I do Redis CLI-X, and then I'm just going to redirect. I got a file that has this query in it. I think it's historical counts. We change it to my queries directory. Let's go ahead and make that tall. X, type in historical counts.redis. So if I show you this file here, this is just that query in one string. That's all it is. So, and run it. Then here it gives me the year 2016, month 9. There were 2 Bigfoot sightings. 2016, month 10, there were 3 Bigfoot sightings. Right. So fairly basic command in some ways. Basic useful data though, very useful data. And it creates this this chart here, which well, actually what I did was I ran this thing through the Redis Insight here. And one of the things you can do is you can export entire data as CSV. So I exported it as a CSV, put it into Google Sheets to make this little chart. But what's interesting about this data is there's a couple spikes that happen, one in the mid 70s here, and one in around in the mid 90s it started increasing. And then around 2008, it started declining again. And I think this data is really fun because one fun thing is that in 1995 was actually the year the X-Files first came on the air. And so when the X-Files came on the air, the sightings started to increase. And then in 2008, when this data starts to drop again, that's actually when the X-Files went off the air. Sometime in the mid 2000s, I think it was 2008. And so you've got this this jump and drop. What it really is, of course, is 1995 is this is the internet happening, right? The internet happened, and all of a sudden, everyone could tell their Bigfoot stories to people on the internet. And 1995 is also the year the Bigfoot Field Researchers Organization established their website. So those two things together have caused, really caused this spike. The 70s, I think this is just what the 70s were like. I remember the 70s, and the paranormal stuff was kind of fun back then. So that's the one interesting thing that stands out in this data. But the other thing is that it's spiky, right? It goes up and down and up and down and up and down. And if we run another query, we could get a little bit of understanding of why it does that. If we run this query here, we're saying, what months do Bigfoot sightings happen on? So here, this is a very similar one. We're searching for all Bigfoot sightings. We're filtering on the timestamp, and then we're getting the month of the year, and then we're going to group by that month and count. So this will give us a count of all the Bigfoot sightings in our data set. What months do they occur onto? But what's the frequency for each month? And if we look at the data here that we get from that, we see that the winter, the most Bigfoot sightings are in October, and the least are in February and March. And July is a pretty high one too. And this makes perfect sense. This is in North America. This February and March is the dead of winter. It's cold out there, right? This is when it's this is in Ohio where I live. In February and March, we can get weeks at a time where it's -5, -10 Celsius. It's very cold, and so it's not. No one's outside looking for Bigfoot. Everyone's at home, and so the sightings drop. And if we look in the summer, in June, July, August, September, we start to see them increase. People are going outside. They're doing stuff. And October is particularly interesting because the weather's nice enough in North America in October that people are outside. It's cool, but not cold. And all the leaves have fallen, and so you can see everything really clearly. And so you can see further. And so October is when everyone can see through the woods and they're outside doing things. And so this has more to do with people and their ability to see than it has to do with Bigfoot. Bigfoot doesn't hibernate. It's just people seeing the data. So this is kind of fun data. And then this is reinforced by the idea of this query here, where I'm saying what day of the week do Bigfoot sightings happen on? This is basically the same query, but I'm grouping by weekday instead of a month. And if we look at the chart here, look at the data here, we see that Saturday is by far the most common day for a Bigfoot sighting. And this is the most common day for someone not to be at work and to be outside enjoying nature. And so I like to camp in the U.S. I realize that's a U.S. thing, and the Brazilians aren't really into camping necessarily, because it doesn't usually end well. But in the U.S., I work all week, and then Friday night after work, I pack up my gear and I go out and I find a place to camp. I set up my tent and get a fire built and have a nice quiet evening at night. And then I spend all day Saturday at the campsite and in the woods. And then Sunday morning, I break camp and leave. So Saturday is the day I'm most likely to spend in the woods of any day of the week. And so it's also the most likely time you would find a Bigfoot sighting. So I've already demoed these queries as well. So that's pretty much my talk. Here's some resources to check it out. Redis.io is, of course, where you can get Redis. RedisSearch.io is where you can get RedisSearch and get all the documentation, where we can find out what the C library is that it's using to do the searches. The Bigfoot Field Researchers Organization, the BFRO.net, is where all that wonderful data is at. If you want to try out Redis search without having to download and install a bunch of stuff, you can just use the Redis Cloud version. You can go to redislabs.com/Redis Enterprise Cloud, sign up for a free account, add Redis search, and start playing. If you want to play with this data set yourself, it's out there at data.world. This is the Bigfoot data set that Timothy Renner put together. And Timothy Renner has some great stuff on his blog. He hasn't blogged in a while, just like me. But go and check out his blog. He's got some great analyses of this data as well. And all the codes, slides, and everything that you could care to know about this talk are out here at this QR code and at github.com/guyroyce/finding-Bigfoot. So go ahead and scan that QR code. If you were here last time I spoke, you know that this QR code is safe and it's not going to rickroll you. So I'm not going to make that joke again. And any questions real quick? I think we got most of the questions during the talk, but if there's any other questions here real quick, I'd be happy to entertain them. The Redis channel is awesome too. Thank you very much. We've got a lot of, I'm one of the dudes on the YouTube channel a lot, it seems, but We actually got a live show that we've been running as well. You can go to, I don't have a link to it handy, but it's at meetups.redislabs.com/Redis Live. Where we're doing like a monthly streaming show, kind of like this, but Redis themed. So it's like Redis month, but only once a month. So,
Oh,
other things to check out are we got Discord server, YouTube, Redis University. Sign up for some free classes, ask questions on Discord, and watch our awesome videos. I'm Guy, and thanks.
yeah, you are the guy. Actually, I have a question. Will
Yes, sir.
this live be recorded in our channel? Because I have to apologize with all of you because I lost my internet connection in the middle of the session, so I lost almost everything.
I think StreamYard should save a copy of it, though, for you. You should be able to download it from StreamYard.
Yeah, actually, it was a joke, but I think I lost the punchline.
Oh, sorry. I thought you were serious. You were. It's because you're using conference Wi-Fi, isn't it?
Yeah. Actually,
and then Jose's asking for the Redis meetup. Yeah, sure. Let me do a dangerous thing and bring a browser window up.
okay. And just saying, all the social networks, the social media of Guy is in the video description.
So this is
go there and check it out.
So this is Redis Live. Yes, cookies are fine.
We all love cookies.
And you can go out. And so here is in August we have Anders Astrom coming to speak about Red Grease, which is a library that works with Redis gears. Don't have anything scheduled between September and out yet, but I'm working with speakers. All of our past events are out here as well, so you can go and take a look at here's a full text search workshop that one of my coworkers did. You got, and the YouTube video is actually embedded right there, so you can go watch it. So go check it out. Lots of free content. Free is good, right?
Yeah.
So
the link is in the comments. So if you want to check the meetups from Redis Lab, just click there and go see their content.
Yep. So that's all I've got. If there's not any other questions,
I don't think so. So
cool.
Far, so good. So as I said, I lost most of our talk, so I'm not sure if you answer all the questions in the session. So I'm so sorry.
I think I got most of them.
Okay. So, guys, I
think I got all of Jose's questions. And how do you say that in Portuguese? I know I'm doing the Spanish pronunciation. I apologize. I know I'm saying your name wrong, but I don't know the phonology for Portuguese. Is it?
Sorry?
Jose's name. How's that said in Portuguese? I'm saying it wrong. I know.
Jose.
I got it. Okay, so the J is a J. Got it. So cool. So sorry, I've been saying your name wrong the whole time, Jose.
So Jose Silva said it was well presented, all questions answered. So I just saw his questions before that, and you got everything. So thank you to being the presented speaker and the host today.
Well, thanks for having me. I'm always happy to talk, and if I can help out in the future, let me know.
Okay, then. So I think that's it. You have anything more to say, Guy?
No, that's pretty much it.
Okay, then. So thank you, everyone, to watch this. Thank you, everyone, to enjoy. I think you need to stay tuned in our social medias just to see everything we are doing. And a special thanks to Clady. She is in this room because I was thinking my internet wasn't come back, and she's here. She's helping me. So thank you, Clady. And thank you, everyone. I think that's it. I will end the transmission now. Okay.